in plants. Even plants require nutrients. Apart from water, they also have requirement for nutrients just like animals. Soil is providing this nutrients. The majority of the nutrients is obtained from soil. Through the soil solution they take up. We have already discussed about the uptake of minerals in plants through the translocation of water or ascent of sand. I have already told you there is a uptake of minerals along with water. Okay, they are dissolved as ions. So what are the minerals? There are nearly 105 elements are there, of which nearly 65 mineral elements are, 65 and more mineral elements are required for plants. But of which 17 are essential elements without which there cannot be a normal growth and reproduction in plants. Okay, that you have to remember. But plants also can grow without soil in a water solution, provided you add them or provide this water sample should have macro and micronutrients. So growing plants without soil in a nutrient solution, we call it as hydroponics. We call that as hydroponics. So Julius von Sachs has done a lot of work on this nutrients, wherein each and every nutrient he has taken up, found out how much amount of nutrient is required, how much, too much also what is the problem, and too little what is the problem if the minerals are present. Deficiency and excess of nutrients, he has studied about Julius von Sachs. So Sachs, that you can remember. Hydroponics is growing plants in a nutrient solution without soil, we call that as hydroponics. There is a pot in which the nutrient solution is there, which has macronutrients, micronutrients. So they have holding here, they're using a cotton plug. We have put them into the, what do you call it as a pot with mineral nutrients. The pot has no opening at all. They have only mineral nutrients, no soil is there. But they also require aeration because even roots require oxygen for the growth. Okay, aeration of roots is required. So there is an aerating tube that we have added up. And we also have a funnel through which we add water and nutrients. Whenever they get low, we add the water and nutrients like this. And one of the hole, it has a plant, a fixed plant which grows utilizing the minerals, nutrients from the solution, nutrient solution. This is an experiment setup of nutrient solution culture of a plant. So soil is, one is to encourage purpose, they hold the plant. Another is they are the major source of macro and micronutrients for the plant. You have to remember about that. So the essential mineral nutrients, which are 17 in numbers, and apart from essential nutrients, there are beneficial nutrients also, which are like sodium, silicon, cobalt, and selenium. They are beneficial. But essential elements without which they cannot survive. So you have this essential mineral nutrients divided into two types: macronutrients and micronutrients. In macronutrients, what you can notice is they are having greater than 10 to the power 10 m mole per kg. If it is greater than this 10 molecular weight, probably 10 m mole per kg, then we consider them to be macronutrients. If it is lesser than, the plants require the element in lesser than 10 m mole per kg, we call them as micronutrients. If they require greater than 10 m mole per kg, we call them as macronutrients. If it is lesser than 10 m mole per kg, we call them as micronutrients. So I have given some mnemonics for all these elements. Macronutrients, you can remember it as CHOPS, C, KMG. CHOPS, C stands for carbon, hydrogen, oxygen. P stands for phosphorus. Okay. The N stands for nitrogen, and C stands for calcium. They are all macronutrients. Okay. Then KMG, K stands for potassium, Mg stands for magnesium. So these are all the macronutrients. You can remember by this code by CHOPS, NC, KMG. Where C stands for carbon, hydrogen, oxygen, P stands for phosphorus, Mc is nitrogen, calcium, Kmg, potassium and magnesium. Mn is manganese. Magnesium is present in the chlorophyll also. So we discuss it as a macronutrient. We discuss about that later on. Okay. Micronutrients, they are having this given formula Hymamshu. I stands for iron, Mn stands for manganese, C stands for the copper. Okay. Mo molybdenum, Z stands for zinc, B stands for boron. Then you have N nickel, Ch stands for chlorine. These are all micronutrients. Ch stands for chlorine. You can remember all the 17 elements, micronutrients, using this code words or mnemonics. First letter I have taken and I have coded them. Okay. So Imnc, you can easily remember iron, manganese, then Cu is copper, then you have MoZB, molybdenum, zinc, boron, nickel, chlorine. Mnc you can remember as molybdenum, nickel, chlorine. So that is how we can make code words and remember about this essential macronutrients and essential micronutrients. Now, what is the criterion for the mineral nutrients? Okay, so the criteria for essentiality to be considered as nutrient. They have given here the various criteria. It should be absolutely, for 2 marks they may ask you, absolutely necessary for the completion of life cycle plants. And without this, there cannot be normal growth and reproduction in plants. So those elements we consider them as essential elements. So the criterion, the parameters for any element to be considered as essential element is, it should be required for completion of life cycle of plant. And without that element, they cannot exhibit normal growth and reproduction. Such elements are called as essential elements. That is one of the parameters for categorizing any element as essential element. What is the second criterion? Its requirement is specific. This much amount should be there. A specific amount it is required and it cannot be replaced by any other element. So only then you can call them as essential element. Third criterion is directly involved in the metabolism of the plants. The sum total of chemical reactions taking place within an organism, we call it as metabolism. The sum total of chemical reactions taking place within an organism, we call it as metabolism. For this metabolism, this element should be absolutely required. Only then you can call them as an essential element. Three things. Essential elements are required for completion of life cycle of the plant and for normal growth and reproduction. Essential elements cannot be replaced by any other element. Second criterion. Third criterion, they should be directly involved in the metabolism of the plants. That is, various chemical reactions which are taking place within the plants. These elements are directly involved. Only if they fulfill these parameters, we call them as essential elements. So even though there are 105 elements, of which 65 and more are required for plants, of which only 17 elements we call them as essential elements based on this criteria. They have identified each and every element by quantitative and qualitative analysis by performing experiments in the plant. Wherein in the solution they might have had only one element and in different quantities they might have found out how much is required. If it is excess of it, what is going to be the harm? If it is deficient, what is going to be the harm? By experiments we have identified all these elements. Okay. So and we have listed them as macronutrients and micronutrients. So essential elements are 17 in number. Apart from that, beneficial elements are also there. So which are listed out as sodium, silicon, cobalt and selenium. They are all beneficial elements. But 17 essential elements are required. So macronutrients, I have already told you what are the criteria for macronutrients and micronutrients. So I have given you that code word also. Now the essential elements based on their diverse functions in a plant. We can categorize essential elements based on their diverse functions. 4 categories we can have. Based on their functions, essential elements can be categorized into 4 types. First type is structural element of cells. They are involved in the cell wall, cell membrane and other things. So we call them as structural element of cells. What can they all be? They can be carbon, hydrogen, oxygen, nitrogen. John, you can remember it as carbon, hydrogen, oxygen and nitrogen, which forms the structural element of the plant or the cell. They give a definite shape and structure. So structural element of a cell based on if they are involved in structural element of cell, that is one category of essential element. Second category, energy related chemical components. ATP. What does it have? Phosphorus, isn't it? Adenosine triphosphate. So it has phosphorus. So that is one more aspect of the components of energy related essential elements. You have the chlorophyll and phosphorus. Chlorophyll will be having what? Magnesium. The macronutrient. So magnesium. Then there is also the phosphorus and ATP. So energy related chemical component. Those elements are found in this energy related chemical components like chlorophyll and ATP. Okay. Then activate or inhibit enzymes. Some of the elements they can activate an enzyme. Some of them they can prevent the functioning of an enzyme. Enzyme is a biocatalyst. You know that, and they are required for various reactions to take place. For the reactants to react, enzymes are required. So that is the reason enzymes are called as biocatalysts. So you remember about it. So there is one element like molybdenum. So they are going to act, enzyme nitrogenase is activated by molybdenum. You can remember one example for that. So some of the elements are involved in activating the enzymes or deactivating the enzymes. Deactivating is inhibiting the functioning of enzymes. Molybdenum is going to help in the nitrogenase enzyme function. MO you can remember. This is an element. Micronutrient. Molybdenum is a micronutrient. The fourth part of is that they alter the osmotic potential of a cell, especially the opening and closing of stoma. There is a potassium ion pump theory, we call it as influx and efflux of potassium ions. They change the osmotic potential. Okay, water potential, osmotic potential, you know about it. So once there is a difference in osmotic potential, there is going to be endosmosis or exosmosis. Based on whatever type of process occurs, there is either opening of stoma or closing of stoma. Stomatal dynamics we call it as. That is proved by the potassium ion pump theory, wherein they talk about the entry and exit of potassium ions. So they are also involved in altering the osmotic potential of a cell. See, potassium is osmotically active. Whenever they enter, so they are going to help in endosmosis. Whenever they exit, they are going to help in exosmosis. So as a result of that, you find the opening and closing of stoma. During daytime, stoma is open, and during night time, stoma is closed, except for CAM plants, crassulacean acid metabolic plants, where I told them they are like call center employees. They stoma is open during night time and closed during daytime. They help in avoiding transpiration through stomata. Okay, so you have to remember about this types of it. Based on the diverse function, the essential elements are broadly categorized into four types. First one is structural element of cells. They are involved in giving a definite shape and size. The elements are CHON, carbon, hydrogen, oxygen and nitrogen. Then there are energy related chemical components like the presence of Mn, manganese in chlorophyll, and the presence of phosphorus in ATP, adenosine triphosphate. The energy currency of the cell is ATP. You should remember about that. Adenosine triphosphate. Okay. Then they activate or inhibit enzymes by their presence. These essential element. So the third category of essential element based on their function. Molybdenum activates nitrogenase enzyme. Then they alter the osmotic potential by potential of a cell by its entry or exit. Potassium ion is an osmotically active compound, and they bring about the opening of, whenever they enter into the guard cells, they bring about the opening of stoma because of endosmosis. Whenever there is efflux of potassium ion from the cell, there is a closing of stoma because it leads to exosmosis. And potassium ion is osmotically active. You have to remember about So these are some points that you have to remember regarding the minerals, essential elements, mineral nutrients, macro and micronutrients. A few of them I'll be discussing their functions, okay, and their role. Nitrogen, a few of them I'll discuss, at least 4 of them. Nitrogen, they are absorbed as nitrites or nitrates. Nitrates is the form in which they are absorbed. We'll also be discussing in this chapter nitrogen cycle. Plants can absorb nitrogen only in the form of nitrates, but they exist as nitrites, nitrates, ammonium ions. But plants can absorb nitrogen only in the form of nitrates. Okay, so they are required by all metabolically active cells because they are macronutrient. Nitrogen is macronutrient. NPK, farmers use NPK. What is NPK? Nitrogen, potassium and phosphorus. They are required for the plants. So farmers urea they utilize. So through different process they add up this nitrogen, potassium ion and phosphorus, which are macronutrients required for the growth of the plants. So they are required by all metabolically active cells and growing tissues, which we call it as meristematic tissues. Phosphorus, they occur as phosphate ions. Okay? So they constitute the cell membrane. Cell membrane, you remember about fluid mosaic model of plasma membrane. White phospholipid layer. What do they contain? Phosphorus. Even the nucleic acid contains phosphorus. See, nitrogenous base plus sugar plus phosphorus, we call it as nucleotide. Without phosphorus, we call it as nucleoside. So phosphorus is present even in nucleic acid, that is in nucleotides also they are present, and required for ATP formation. Phosphorus is very important. They are also required for ATP formation in all the organisms, whether it is plants or animals. So universal energy currency, whether it is in plant or animal, is adenosine triphosphate. You should remember that. Potassium ions. I have already told you for opening and closing of stoma, potassium ion is required. Apart from that, they are required in abundance by meristematic cells, buds. They are all growing part of the plants. Meristematic tissues, buds, leaves, root tips, they require this potassium ion. For them to normally undergo cell division, they require all these. They also, potassium ion balances, maintains anion, cation balance in the plants. So these are functions of this potassium ion. They are involved in opening and closing of stoma. I told you that this mechanism of stomata, opening and closing, or stomatal dynamics. There is a very important theory called as potassium ion pump theory, where there is an entry and exit of potassium ion based on which there is opening and closing of stoma. Okay, still here, it's sufficient.